So now let's go one step further from the mobile ad hoc networks. Let's go to wireless sensor networks. Okay, what has this to do with mobile and wireless communications? Well, most of these sensors are connected via a wireless link to some infrastructure, or you can even set up an ad hoc network. But, well, what is the difference? Well, it's also self-organizing, wireless, should be energy efficient, but the big difference here is, while thinking of mobile ad hoc networks, you may still think of laptops or routers, but now ad hoc settings. But here, well, we have specialized devices, environmental monitoring, for example. So more specific. The devices are usually battery-driven, limited power, embedded systems, interacting with the environment, sometimes also called cyber-physical systems. Well, manets, well, maybe you think of dozens of devices, maybe 100. Sensor networks, you think of thousands of devices, tens of thousands of devices. Furthermore, in manets, you still have something like a node, maybe with an IP address. In wireless sensor networks, you don't care about the single nodes. You look at the data. You want to have the average temperature of a certain region, the average rainfall. No matter which node now collects this and how you calculate the average, should be the average. Mobility patterns can be quite different. Quality of service, energy, cost per node is really different. So if you look at sensor networks, well, typical setting is, well, it's an ad hoc network, yes, but maybe you have some more powerful gateways. You see, this is this kind of clustering, hierarchical approach to handle scalability. So more powerful gateways and simpler sensor nodes, and those nodes, they process the data and forward via radio, and then maybe over several hops. That's quite common. Network is self-organizing, but you need some kind at least of gateways that then connect this to other networks. So if there's a fire in some region, some or several nodes will report this. Maybe they collect the events, the alarm, forward the alarm. That's the idea. Low-cost devices, some euros, some dollars, that's it. But at least able to perform some simple routing, some forwarding of the data. Okay, so applications, without going into all the details, wireless sensor network starting, say, early 2000, vehicle monitoring, health, medicine, long-term monitoring of patients, intelligent buildings, smart buildings, building monitoring, all these things, individual climate in rooms, mechanical stress detection, environmental monitoring, very interesting monitoring of wildlife. We once monitored the Manx shearwater, little birds, and all these things. So monitoring of wildlife, person monitoring, waste dumps, demilitarized zones, etc. Total asset management, so logistics. So all these wireless sensor networks, they're quite often complementary to fixed networks. So that's many different applications where you say, okay, we have some sensors, they somehow self-organize, and then they send some value to some sink, and then we process this. And based on this, over the last years, we have now this paradigm of the Internet of Things. Well, also the wireless sensor networks, they were connected to the internet, but sometimes some different protocols. And now everyone is talking about the Internet of Things. All cars, but also energy, grids, buildings, healthcare, etc. Everything is connected somehow to the internet. Okay, everyday things, machine-to-machine networks, etc. Sounds nice. What is the idea? Well, this is kind of a cyber-physical system. If you interact with physics, with systems, this is a wireless sensor network if you sense something. But now the thing is that the internet technology, so our internet protocols, are now inside of everything. That's the idea. Well, many think this is a new idea coming up, let's say 10 years ago. No, it's not. It's quite old. Mark Weiser already said, beginning of the 90s, well, the computer of the future will disappear. Disappearing computer. Kevin Ashton coined this term Internet of Things more than 20 years ago. So kind of enhanced radio text. But today we say, well, Internet of Things, this is a network of somehow connected, embedded mini computers. You collect data, you distribute, you use internet technologies as a common platform. So that's important. No strange proprietary protocols. Neu aufsetzen. No strange proprietary protocols. You may have RFIDs, or radio frequency identification, wireless sensor networks, some actors, some smart whatever, some cyber physical systems. So this all comes together. It's a next generation of embedded systems plus sensor networks, plus actors, plus internet protocols. So great. Already today we have billions of these devices, more than people connected. Estimations, that's always difficult. 25 billion or 50 billion this year. Okay, we know there are many and we will make a lot of money out of this. What is really new and what has this to do with mobile wireless communications, the topic of this lecture? Well, not the miniaturization, that's just to make the picture complete. Small devices, very small devices. Also small operating systems, so we have one of our own, Riot, 1.5 kilobytes of RAM. We can use now many of the new technologies. Cloud computing, edge computing, fog computing, big data, IPv6, 6LoWPAN. I will explain a bit more about this. Now content-centric networking, we have everything is new. We know these are restricted devices, no real firewalls, no antivirus, whatever. But we all use the same protocols, or at least similar protocols as we have them in the internet. So this is quite complex in terms of number of nodes, topologies, different traffic patterns, stable, maybe not. A lot of legacy stuff in there. So all this comes together now. Many new possibilities, but also vulnerabilities. But this is left to our security lectures. So 6LoWPAN. This is another protocol used in this scenario of the Internet of Things or wireless sensor networks, etc. 6LoWPAN, that means IPv6 over low power wireless area networks or wireless personal area networks. Many RFCs. What is the idea? Well, assume we have ZigBee devices 802.15.4. I introduced them. And they're always limited in power, in memory, in energy. You want to have long sleep cycles. You have unreliable devices, ad hoc deployment. That's quite common. You have no professional deploying this, you just deploy it somewhere. And this is self-organizing somehow. And we have many devices. But now we want to run the internet over these devices. There's the big problem. The MAC layer, well, offers only up to 81 bytes for the data, for the higher layers, IP layers. There are limitations in the physical layer, plus there are some security mechanisms included, which is important. The IPv6 header already requires 40 byte. Now we assume UDP, not TCP, could also use TCP, but UDP on top of it. So this leaves, in the end, only 33 bytes for the payload. That is not too much. So you have the layer 2 header, encryption. You have the payload, but there's already a lot used by the IPv6 address, 128 bits, great. UDP, small payload. So the idea of 6LoWPAN is, let's compress the headers. Because we know a lot, this is something for the computer network class, how to create an IPv6 address, that basically you will see the MAC address in the IPv6 address. You can compress quite a lot if these are so-called linked local addresses. We can compress the UDP header because we don't need that much. Well, we need ports, but what else? We don't need checksums, things like this, for example. So in an ideal case, we can compress all this down to something like, 7 bytes, for example. This gives us more space for the payload. 6LoWPAN does more. IPv6 says, okay, the MTUs, so the message size, should be at least 1280 bytes. That's way too big. So 6LoWPAN also performs fragmentation. So it's kind of an adaptation layer between the link and the network layer. So after leaving this Zigbee or whatever network, our wireless sensor network, IoT network, then we translate back into normal IPv6 packets. There are some more special fields, dispatch field, not important here. But that's the basic idea. We do not need all these big addresses, and we simply compress, leaving more for the payload. Okay, also here, some questions. Think of mobile and wireless communications. What are the specific challenges if we think of wireless sensor networks or IoT in general? And which problems arise using classical internet protocols together with, this example, Zigbee.15.4? There we have some special problems.